Okay, another favorite cluster of the June Regents exam. So this was our cluster set on the ghost forests. And again, I think a lot of people were caught up on the fact that their teacher may not have taught them what a ghost forest was, but you did not need to know what a ghost forest was because they told you in this paragraph exactly what a ghost forest was. So it says a ghost forest is a term used to describe a group of dead trees or tree stumps that remain standing. Ghost forests often form due to environmental change or natural disasters that impact coastal forests. As sea level changes, the invading seawater can advance and overtake the fresh water that many tree species in coastal forests need to exist. Okay. So what they're telling us is basically you have a group of trees that are dead and they have formed because the salty water on a coast, so coastal means near like oceans, has overtaken the fresh water that the trees needed to survive. So it says the water slowly poisons living trees, leaving dead and dying timber. Ghost forests can be found in almost every coastal state in the United States. Okay, so they've just basically died from the salty water intruding the area that they live in. Coastal forests serve as efficient carbon sinks, collecting and storing atmospheric carbon. They are critical for maintaining water quality as they naturally filter, cool, and slow the movement of groundwater and streams. Coastal forests protect against erosion, buffer storm surges, provide wildlife habitats, and ensure water quality and quantity. As saltwater intrusion intensifies, the supply of coastal wood needed by the timber industry will also shrink, harming the economy of rural areas that depend on it. So they're telling us kind of the benefits of these forests. So they help to remove carbon dioxide. They help to filter and move groundwater. They help us in storms. They give habitats, and they help to give good water. Okay, and they also mentioned an economic impact in the fact that the timber industry uses these trees to build things. And so now if we're taking those trees away, they cannot use them anymore. Okay, so it's going to negatively impact them. So the graph says the graphs below show some information about global temperature, CO2, and sea level. An anomaly is a change from an expected value. An anomaly value of 0 represents no change from the historical average. Okay, so we have CO2 concentration on this side, and we have sea level over on this side. So that's kind of my big difference there. So we have sea level, and then we have atmospheric CO2 concentration and surface temperature. So this gave us kind of both things here. And it tells us that our dashed line is our surface temperature and our straight line is our CO2. Okay, so it says, in addition to increased carbon dioxide emissions, which row in the table below correctly describes the factors and their effect on coastal flooding in areas where ghost forest land cover has increased from 1920 to 2020. Okay, so my first row is the total change in temperature anomaly. Okay, so I'm going to look at this graph here. So temperature anomaly, and I see that the scale for temperature anomaly is, I'll highlight that in orange, is this side. And my temperature anomaly is the dashed line here that looks like this. Okay. And so the first thing I notice is that these are all the same value, but 2 of them are negative and 1 of them is positive. So I'm going to start there. So I'm going to say, okay, from 1920 to 2020, so there's 1920, 2020, I went from about negative 0.1 to positive 0.8 almost. Okay. So I went from negative 0.1 to positive 0.8. Okay, so I changed. Did I go in a positive or negative direction? I went from negative to a positive. So that means my temperature anomaly was positive. So I do not want row 1 or 2 because they have negative values. Okay, my total global sea level anomaly. I'm going to look at the graph over here that was in blue. Sea level anomaly. Whoops. And I'm going to look right there from 1920. So I'm about negative, negative 140 maybe. And it goes up to about maybe 60. Okay, so I went from negative 140 to positive 60. Okay, so I'm going to do in my calculator. Now, if you have a calculator that does not do negatives, so if we do negative or 140 negative, we just flip them around like 140 negative. There we go. Minus 60. Our total change was about 200. Okay, so if I look, I had a change of 195 or 70. 195 was much closer to the value that I got, so I'm going to choose 195. So my correct answer was number 3. Okay, our next one gave us another model here. So it says the infographic below shows the predicted development of a ghost forest in a coastal area near a residence from the year 2020 to 2100. Brackish water is a mix of fresh and salty water. So they're telling us it's a prediction, so it's showing us into the future. They clarified that brackish water means salty. So I'm just going to look at what happens from one picture to the next. So my first thing I notice is that my wetland, my freshwater forested wetland, seems to have started to die by 2060. So I see this dead tree here. These are more gray, where they were like more full here in this original photo. I noticed that I have my water table has increased, so it's closer to that forest here. So that's changed. My water table has risen. And I can see that because they marked 2020, this dashed line. And I see my well, and I notice that there's a closer distance from the well to the brackish groundwater, right? The brackish groundwater, means it's like salty and fresh. It's not really water I want to pump into my home to use for drinking and cooking and stuff like that. Okay. And then if I go down to 2100, I see that now I have a ghost forest form. So that's completely gone in terms of those living trees that were in the middle there. My water table has risen even further. And now my brackish water, my salty water, has moved into my well. So I'm now pumping water, salty water, into my home. So 37 says, based on the infographic, identify one natural resource that will be affected by the rise in sea level and construct an explanation for how the change in the availability of this resource will affect human activity. Okay. So freshwater natural resources, right? So natural resources are things that we use that are found in nature. And those would be things like, we typically use them for like human survival, or we use them for financial needs, right? So things we can make money, economic benefits. Okay, so those would typically be like water, air, soil, plants, minerals, fossil fuels, right? Coal, oil, gas. Those would be natural resources. Okay. And so I had a couple of choices here. I could talk about the initial change in the forest. So that would be a natural resource. So you could say trees. I could talk about the water, right? So we also have a well here that humans would have needed to use that fresh water. Okay. So I'm going to give you two things. So you could have said fresh water. And I'm going to write in blue down here kind of what my effect on human activity would be. So if I had chosen fresh water, then how would that affect human activity? Well, I can't really drink salty water. And so I would have to either move my well, I would have to move to a new location. I might have to find like other sources of water or get a filter of some kind. So I would say like people would have to move their well, home. Okay, so that could be one solution there. The other thing you could have talked about is trees, right, or wood. Could have been another natural resource that would have been affected. And they talked about how the timber industry relies on wood for their economic advantage. So we could have said something like there would be no trees for the lumber industry, right? Or you could say like to build houses. You could talk about how there would be no lumber for heating, right? Building. Okay, something like that if you chose trees. Okay, 39 38, a student makes the claim that the amount of living forest acreage will decrease as the amount of ghost forest acreage increases in the coastal area near this residence. Which associated impact to an earth system will most likely occur? So if I have less living forest, I now have more ghost forest, and that would be true, right? So if as my living forest dies, my ghost forest amount increases. Wants to know what would happen because of that. So 1 says the increase in wetland area will decrease local humidity. 2 says the loss of ground vegetation will cause an increase in water runoff and soil erosion. Okay, so I would say number 1, if I'm going to increase wetland, I'm probably not going to decrease humidity, right? If I add more moisture into the area, I'm not going to decrease the humidity. 2, the loss of ground vegetation will increase water runoff and soil erosion. That is true, right? If I have less trees and plants to anchor the soil, I'm going to have more runoff, and that runoff is going to erode more of the land. Okay, so 2 looks pretty good. As high tide water levels increase, the local climate will cool due to more solar energy being reflected. So water does not reflect. Water is going to absorb more, right? So typically, if my water level is increasing, like it's not really even gonna okay, so let's say the amount of water is not going to influence how much is reflected per se, right? So we talked about like an ocean exposed in the Arctic versus like white ice, right, is going to reflect or absorb differently. But in this case, like rising water levels is not really going to change that enough. So 3 is not a great option. And then 4, new species that live on dead and decaying wood and ghost forests will increase the biodiversity of the ecosystem. Again, so like those dead and decaying trees, you're going to lose animals at the same time, right? So our best answer here that we can support based off of like what we're reading about is answer number 2. Okay, the next one says the model below shows the effects of subsidence in the creation of ghost forests as a result of an earthquake that occurred on January 26, 1700, along the west coast of the United States. Okay, so we have from 1700 to present day, we have the forest in its initial condition, then we have the flooded forest floor, and then we have the actual ghost forest being formed. Okay, so it took from 1700 to present day. And then we have this little mark in the middle that says land subsides during earthquakes. So that's happening right here. And it says use the model to compare the temporal scale of land subsidence associated with the earthquake to the temporal scale of land subsidence associated with the development of the ghost forest. Remember, temporal means that we have to talk about time. Okay, so I need to look at the earthquake first. So I've noticed that the land subsidence during an earthquake is going to happen right here. So it happens in between January 25th, 1700 to January 26th, 1700. So it took about 1 day, right? So it happened very quickly. As soon as the earthquake occurred, that land subsided. And then I have to talk about how that compares to the development of a ghost forest. So I see that my ghost forest starts here, right? There's my initial, and it forms present day. So like hundreds of years later, okay? So my subsidence during an earthquake happened much quicker than my subsidence in terms of the formation of the ghost forest. So I would have said for earthquake, I might have said something like happens very quickly in days, right? And then my ghost forest took a really long time. So happens over hundreds of years. And that's it. That's my comparison. Okay, my last one says 6